Hello everyone, I'm Dan, and today we're going to be talking a bit about Fusion. Now, more specifically, we're going to be talking about some changes that have been sort of stewing in the back of my mind for a while, which I think could have some rather interesting implications on the sort of design and performance of Fusion going forward. How easy is it to use? How reliable is it? What guarantees can you make? So this is all to do with a rethinking of one of Fusion's most central components, which is dependency management. So the idea of Fusion has always been to try and really dig into the details of the relationships between your individual variables to try and optimize how they're calculated. So we can sort of like take a look at, okay, what other variables does this one variable rely upon, and how little can we update that? Like, how much can we get away with like caching this value? How often can we reuse it? And in general, how quickly can we terminate updates, right? If something hasn't changed or if something doesn't need to be updated, we can obviously like cut off the updates immediately. So it's sort of become this game of like trying to keep the update sort of like the length of updates as short as possible, updating as few things as possible, and having the most information we can reasonably access about how everything relates to each other. So this is a very complicated problem. So the first solution to this is something called static dependencies. And these tend to be explicitly defined up front. And this is something you see with frameworks like Blend. So we say value 1 is, 50. Well, let's give it a more descriptive name than value 1. We'll call it width. And height, value 25. And area will be computed. And because these are static dependencies, you have to declare them up front. So we'll do that in an array. So we'll say this depends on the width and the height. And we have a function, and we'll just say return width get times height get. Right. Now, in simple examples like this, static dependencies, they're fine, right? I mean, it's a bit boilerplatey. It's kind of not ideal that we have to define the same thing twice. But I mean, it's a reliable solution. You know that if the width or the height changes, area will be recomputed, and you can make that strong guarantee. You know that nothing else will affect the area. It's very obvious and simple. But the problem is it becomes impossible to express dynamic relationships or really anything more complicated than this. Say, for example, we had local selector, and we're going to use this to select. We can actually, let's do something like this. So we have a selector here which you can use to select what dimension we're looking at. And I'll say local square size, I don't know, and it's computed. It depends on. This won't illustrate the point. So we'll go back to using the Boolean. I'll say dimension. I'm doing this all live if you can't tell. And so the way we're going to program this, we're going to say return if selector get, then width get, else height get. Right, so it's not immediately clear how we would express the static dependencies for this here in an optimal way. The reason why is because it's theoretically impossible. I mean, yes, we could say selector width and height, but this is suboptimal because, say for example, selector is true and we're using the value of width, right? The value of height goes completely unused, but yet if height were to change, we would run that computation again because Fusion cannot know that height has gone unused because the dependencies are static. It's impossible to achieve that level of optimization, right? And the reason why is because we've defined the dependencies up front. They're static, they are unchanging. We cannot update them as we get different information from the program about what it's actually using. this is a problem. And it's especially a problem when you're doing stuff with expensive operations, for example, long lists or big data, anything with like generating instances, this can become a real problem. In general, like with UI development, you find there are lots and lots and lots of expensive calculations that you really don't want to be recomputing without reason, right? And this is especially true if you're sending things off to like remote servers where you don't want to send the same request like a billion times, right? You end up having to do things like debouncing, and it's generally, it's not good. So while static dependencies, on the face of it, seems all right, it's unable to capture complex relationships between variables. It's useful only at the simplest level, though for some applications this is perhaps all you need. So this is where dynamic dependencies come in. So dynamic dependencies is all about trying to capture this information live. So Fusion, we do dynamic dependencies. So in Fusion, as I'm sure you guys are all aware, we can, where's it gone? Yeah. In Fusion, we can do this very same example, except we don't have to declare our dependencies up front whatsoever. So you might be wondering, well, what's going on here? Well, the answer is that Fusion is keeping track of what state objects you're getting the value of, right? When Fusion runs your computed callback here, when it runs this function, it's got a variable set internally which points back to that computed. Then, whenever you get the value of a state object like this, that state object will tell Fusion, hey, my value has just been gotten. Are you currently pointing at any computed? And if the answer is yes, then it adds itself as a dependency to that computed. So in this case, while we're in this function, where we call, while we're in this function, there's that internal variable is pointing to area. And then where we get the value of width here, it says, hey, are you pointing at something? Yes, we're pointing at area. Okay, cool. Add me as a dependency to area. And the same thing happens with height, which is fantastic. All right, so we've automatically picked up that we're using width and we're using height. And so we can add those as dependencies pretty safely. And so area now knows that whenever width or height changes, that area needs to change. So the really good thing about this is that you can recalculate this whenever you like, right? All you need to do is just run the code and see what it does. Well, it turns out that the perfect place to recompute this is when you're recomputing the computed itself, right? Whenever you're trying to recalculate the area, you can simply watch for what's being used. And then whenever any of those things changes, you know that this is the best time to recalculate. And this allows us to capture really, really complicated relationships between variables with as much ease as not doing it at all, right? It's basically invisible. And so, for example, with dimension here, we can capture this conditional dependency, where selector is always going to be a dependency. We always need to know what value we're currently selecting. But if selector is true, then we only depend on width. And if it's false, we only depend on height. The reason why is because when selector is true, we only get the width. And when it's false, we only get the height. Which means that it is impossible for a value that we do not get to ever affect what this value will be. At least within the reactive framework. There's obviously, you can fall back to imperative codes to make workarounds and have side effects and other nasty stuff, but you really shouldn't be doing that, and Fusion doesn't encourage you to do that, so it's not a problem. So this seems like a better solution, and in my mind it is, right? Because we can achieve much more optimal code. We can really cut down on the number of recalculations, we can avoid expensive computations. This is fantastic. But there is a problem here, and the problem is that this is implicit, right? We are not telling Fusion anything about what we intend to be a dependency and what we don't intend to be a dependency. Say, for example, we have a function here, and this function simply gets the height. This is a really useless function. Nobody needs this, right? So just be return height get. And well, if you're calling this function inside of a computed, well, yes, we do want the height to be added as a dependency. That will happen automatically. Fusion will make sure of it. But let's say we added, for example, a debug print, right? And say current dimensions of width get by height get. Oh, it's not in this function's contract, right, to have width as a dependency. Like when you're calling this function, you expect to get the height as a dependency. The width, however, shouldn't be involved. This is an internal implementation detail. The problem is that we can't tell Fusion we don't want the width as a dependency. And so Fusion will just assume that get height should also add a dependency on the width. Which, I mean, yes, we are technically using the width, but we didn't want to add it as a dependency. We can't really specify right now that we don't want this to happen. Well, I mean, that is a lie. There is an internal mechanism that you can use to do this, but it's not documented and it's bad practice to use it because it is a hack. But, but yeah. So basically, this is bad. Right, we want some way of being able to explicitly tell Fusion that we want something to be a dependency, but at the same time, we don't want to add boilerplate code. Well, how do we do this, right? This is a tough nut to crack. So hold that in the back of your mind, because we're going to move on to another topic first. Then we'll come back to this later. So another problem that Fusion currently faces is constants versus state, right? Currently, these are two separate kinds of thing, and you have to deal with them separately, right? So if we take, for example, this very same code here, so width, height, area, selected dimension, blah, 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 and then let's say we change height from a state object to a constant. This is now broken, right? And, well, this is bad, right? Because we haven't changed anything semantically here. The width is still representing the width, the height is still representing the height. We still want the area to represent both of them multiplied together. But now we have to change our code because we've changed the representation of our data. This is not ideal. I mean, it's understandable as to why this is happening, right? Because 25 is not an object, it's a constant. And so we can't use this object notation on a constant. So, I mean, it's understandable why this doesn't work, but it's really inconvenient because we want the semantics to be the only reason why a code change is breaking. Like if you change your semantics, then yeah, your code will probably be broken in more ways than one. Even if it works syntactically, it's probably still going to give you the wrong result. But if you just change the representation of your data, that really shouldn't cause all this code to break because, well, now we're introducing two mental models, right? And this is one of the problems I had with React, was that there was a different way of using bindings compared to diffing, and that's unclean, and it's not good to have these kinds of dualities in any API design. I'm highly critical of them. So it'd be really nice if there was one unified way of using constants and state objects. So one of the early explorations of this idea, and this is something I did actually prototype before I launched Fusion, but I wasn't confident enough in it to ship Fusion with it, was something called makeState. And this is essentially a function that turns a constant into a state object so that you can operate on both constants and state objects in exactly the same way. So what you would do, for example, is you'd say height is makeState 25, and then suddenly all the code works again, right? And I mean, it's not the most ideal solution in the world because we are ultimately creating an object, but you can see why this is appealing because all of our code now uses object notation. This is especially useful in components, which is where this has mainly been a problem. So we write a component like button with props, And I don't know, we just return new button name props.name, right? So, I mean, this is obviously pseudocode, but this is nice and easy because here we're just passing the props through to new. New can handle the difference between constants and state objects for us. We don't have to worry about that. But what if we wanted to prepend something onto this name? Like wanted to have button underscore and then whatever the name property was. Well, suddenly this gets a lot more unclean because, I mean, you can't just do button underscore dot props dot name because, well, this will only work for constants. For state objects, well, you'll get an error here. You can't turn a table into a string. And so you might be thinking, oh, okay, so the Fusion way of doing this, we have to make it computed, right? This is how we always do stuff in Fusion like this. We're trying to transform props.name, so we use a computed to do the transformation. And now we have to specify props.name get, and then suddenly, well, this now works for state objects, which is better because state objects are a superset of constants. Constants can be thought of as state objects that don't change. So this theoretically is better, but in practice, we've just flipped the situation on its head because now if props.name is a constant, if it's just like a string hello, well, hello get doesn't exist. And so this will just cause an error. And so we've really just sort of flipped it on its head. So now you might be thinking, oh, well, what we have to do is we have to say, well, if props.name, we'll say like type of props.name is a table and props.name.type is state. If you're not familiar, all objects in Fusion are tables and they all have a type field which indicates what kind of object they are, which lets you do type checking like this. So we'll just say props.name equals value props.name. So essentially taking the constant and turning it into a state object and then just putting it back where it came from. Now all this code works just fine. And yeah, it's not very nice to look at, right? Look, this is ugly code, right? This type checking, while it's simple in theory, it is boilerplatey code. So the idea behind make state is that instead of doing this, so we just comment it out, we just say props.name equals make state props.name, which does the same thing, but it's much easier on the eyes. And more importantly, it's a standard, consistent implementation of it. So this makes sense, right? You can see where the motivation comes from for this, and you can see that, yeah, it's not the right solution. But actually, perhaps the real solution here is changing how we think about accessing state objects. Because think about what the actual problem is here. The problem here is that we can't use object notation to access the value of a constant. So is there any sort of accessing method that doesn't require us to assume what the object is? And the answer is yes. The answer is functional. So we'll call this functional state get. I don't know. Well, we should probably do that. So the idea here is that we can define a function, and we'll call this function unwrap, and we give it x. We don't know what x is. X could be a constant or it could be a state object. So what we're going to do is we're going to check what kind of object it is. We say if type of x is a table and x.type is state, then we know this is a state object. Otherwise, it's a constant. And this is a relatively safe assumption to make. Right. So the way that unwrap will work is that when you give it a constant, it will just give you the value of that constant, which is itself, right? So return x. But if you give it a state object, it will give you the value of that state object, which is whatever it's holding inside. So it will be x get, right? And this sort of mirrors how we think about accessing a value, right? When we think about accessing the value of a constant, we just use the constant. If we think about accessing the value of a state object, we have to call get on it. This function is basically just that. And the reason why it's called unwrap is because that's basically what we're doing here. If we give it a constant, which is in some sense already unwrapped, then we don't need to do anything. But if we give it a state object, which is sort of like wrapping around a value, then it unwraps it and gives you the value inside. So with this function, we can rewrite our code here. So with width, value 50, height, we don't need make state anymore because we're not using that method. So how do we make this code compatible with both constants and state objects? Well, instead of calling get directly, we say unwrap width times unwrap height, like that. And similarly down here with selector, we say if unwrap selector, then unwrap width, else unwrap height. And for the button example here, we don't even need props.name here. We don't need any of this stuff. Instead of calling get, we just do unwrap props.name. Now let's compare our working between the two methods here, right? Specifically with this component, because components make up a bulk of what Fusion code is. Our code actually ends up shorter. And it's not really that much more verbose, right? It's, you know, unwrap versus get is literally like a naming thing, right? Unwrap is a bit longer than the word get. But you actually notice on the whole, it's still very readable code. It's not boilerplatey at all. And it works perfectly fine with constants and state objects properly, right? We're not hiding away the constants inside of objects. Like, the constants are allowed to be constants. We just process them differently, implicitly, by using unwrap. So I would consider this to be a superior solution to make state, where you don't have to have the overhead of creating objects. We can work with constants as the constants they are, not as anything else. And in general, I mean, yeah, we can't use the object notation that everyone loves to use on Roblox. But actually, this is perhaps more honest, right? Because not everything is an object in Fusion. The only things in Fusion that are objects are the things that need to be objects because they're long-lived. Constants aren't long-lived like that. Constants are simply single values. Whereas objects, like, for example, values or computeds and stuff, these are actual things with life cycles. These are things which need that sort of accounting done. And so our code really should reflect honestly that reality that you're dealing with different kinds of things. So instead of trying to hide away from the reality of the situation, we should be trying to make reality itself a bit easier to work with. So I think that fits this philosophy a lot better. So I think that in the future of Fusion, we will be introducing some kind of unwrap function instead of make state, because I think it's a more elegant solution. I know that I have already approved make state, but I think I might be going back on that decision because this is a very recent discovery. This is something that I've only uncovered recently, right? Because I was thinking about this and I was thinking, yeah, actually a function would work perfectly for this. We don't really need make state. I don't think I will replace get with unwrap for a couple of reasons, right? I mean, obviously the first reason being that, like, we need a standard interface for state objects anyway, because, like, if a third-party library were to introduce their own state objects, I mean, Fusion has no knowledge of what the third-party library is doing, so the get method is a very nice standardized interface for at least Fusion to access these state objects values for you. So whereas the user only has to be concerned with unwrap. But the second reason why is because it doesn't really need to supersede get, right? Like, if you know you're dealing with a state object, then we don't need to force you to essentially type check it with unwrap. You could just use the state object, right? Okay, again, we need to be honest, right? We can't just advocate for one thing blindly over everything else, right? you choose the most appropriate tool for the job. When you know you're dealing with a state object, just deal with the state object. But if you want to deal with both constants and state objects, well, then you use unwrap, because that sort of acknowledges the fact that you are expecting both. So anyway, so from this point onwards, let's just assume that we're moving forward with unwrap. And let's now revisit our earlier problem of dynamic dependencies. So let's copy this down here so that we remember what it is. And I'd like to now introduce a second philosophy of dynamic dependencies. And it's called explicit dynamic dependencies. And this is something that I haven't really seen lots of people explore yet. Though to be honest, I haven't seen lots of people explore dynamic dependencies as a whole subject. I mean, I've seen like JavaScript libraries like Solid.js base their entire reactive system around implicit dynamic dependencies, just like Fusion does. That's where the inspiration came from. But this is still relatively untouched territory. It's almost a bit too untouched. So remember that old problem, right, where we didn't want getHeight to add the width dependency, and in general, we still want to have dynamic dependencies because we want to capture these complex relationships that static dependencies can't. Right, so, well, the solution here is that we want to separate out the act of getting a value and adding a dependency into two separate things, right? Because in this case, they are two separate things. When we want to get a value, we don't necessarily want to add a dependency. But when we add a dependency, right, maybe you don't necessarily want to get the value. You know, it'd be one or the other sort of thing. So the solution here is essentially to give the user some kind of function, like, I don't know, we'll call it use. We'll say use width and use height here. So the user is explicitly declaring, I'm using the width and I'm using the height, add these as dependencies. And then in this case, width get and height get do not automatically add dependencies anymore. So we sort of remove that feature. And similarly down here, we say use dimension, or use selector. And we'll have to rewrite this a bit. I mean, if expression was not the smartest idea for this example. If selector get, then use width, return width get. Else use height, return height get. And then with get height down here, we've solved our problem because we could just use the height without using the width, and only the height gets added as a dependency. Now, I hope this is clear what's going on here, what the actual difference is, right? So instead of Fusion trying to figure out what your dependencies are intelligently, we use the most intelligent resource available, the programmer, and we get them to tell us that they are using what they want to use. Now, immediately there are a few thoughts that go through my head when looking at this code. The first one is that this is theoretically so much better, right? The reason why is because we still have dynamic dependency capability. We can still, you know, capture dependencies sort of conditionally, or we can sort of inject dependencies based on the values of other state objects and stuff. You could do all sorts of crazy cool stuff that you can do with dynamic dependencies, but we don't suffer from the problems that implicit dependencies have on sort of function contracts. Like when you use getHeight, we can now make a strong guarantee that you will only add a dependency on the height because that's the only thing that we are using. And that's something you can't do with implicit dependencies, because with implicit dependencies, essentially all of your functions now become dependent on their internal implementations as to what dependencies they will add, which is bad. You shouldn't be concerned with the internal implementation of your functions, right? That shouldn't affect anything. There should be a visible and easy to define divide between a public interface and a private implementation. So this really serves that goal. But the other thing is that this is awfully boilerplatey, right? We're not going to mince words here. This code is ugly, and nobody wants to write code like this, right? Because, I mean, with static dependencies, it was just a table, it was fine. But here we're actually adding lines of code, and that is taking up space on our screen vertically, which is like, it's the worst dimension to take up space in because screens are short and code spans more vertically than it does horizontally. I mean, look at this screen. It's mostly white space on the right-hand side. So making lines longer is not as much of a problem as making more lines. So this is bad, right? I mean, it's easy to read, it's easy to understand, it's easy to make guarantees about, it's theoretically very beautiful, we still have lots of power here, but it's not very nice to write. So, I mean, it doesn't feel like the right solution, does it? So, let's just continue on with it anyway, because this is what I did. Right? I looked at this and I was just like, this is too good to just give up on. Just because it doesn't look nice doesn't mean that we shouldn't at least try and explore it a bit further. And so the first thing I've realized about this is that this way of defining dependencies actually has a very profound impact on the way that Fusion does dependency management. Because whereas with implicit dynamic dependencies, we have to set a variable internally and sort of reread it whenever we're getting a state object's value. In other words, we have global state. With explicit dynamic dependencies like this, we can actually cut that out. We can get rid of the global state. We can get rid of the automatic dependency manager entirely. And we can just make the state object provide the means of defining the dependencies. And I mean, if it's not immediately obvious as to how that would work, I mean, think about it like this, right? Whenever we call use with a state object, we want that state object to be added to the dependencies of whatever we're currently in. If that use function is provided by the thing you're currently in, well then it's pretty obvious where the dependencies should go, because I mean, the thing that's receiving the dependencies has just created that function. So we don't need a dependency manager anymore. We don't need any global state keeping track of where we're in or whatever. It just, inside the computed, it can just be like local function use x, and it's just be like my dependencies x is true. So we're just adding it to the set of dependencies, and it'll just be like my value equals recalculate with the use function, which then gets passed through to our sort of recalculation function here, and there you go, easy peasy, right? No global state necessary, and that's a good thing because global state, it makes your code a lot less portable, makes it harder to reason about, and in the case of computed specifically, right, this has also prevented us from doing things like yielding in callbacks, or doing like concurrency with like coroutines or actors or anything like that, right? Like back when you had an automatic dependency manager with global state involved, right, you have to be single-threaded, one coroutine, no yielding, has to be instantly done, because otherwise the variables get all messed up. Whereas here, there are no variables to get messed up. You are the one responsible for indicating that you're using a dependency for this computed, so the problem falls to you, and you're the best at solving it because you're the user, you know the context of everything. You don't treat your code like a black box the way that Fusion does. So this has a few knock-on effects. Firstly, this probably has a great performance impact because the automatic dependency manager has to keep track of multiple stacks. It has to do lots of like P calls. It has to do lots of extra processing to really make sure we're adding the right dependencies for the right thing. This does not need any of that processing. It's literally just add thing to table, and that's it. So it would be far less overhead from that, which I suspect would, in some really extreme examples, improve performance. So like if you have a stress test or something, this would probably perform a lot better, which means that it performs a lot better for everyone, which is good. And it means that we're getting closer to optimal performance, which is what we're really gunning for. And so this is good. But the other thing that's really good about this is that it's less magic, right? Because with implicit dynamic dependencies, everyone always asks, how the hell does this work? How does Fusion know that? And when I explain it to you, it makes sense, right? But before I explain it to you, that's black magic. And that's bad, right? We should be avoiding magic. Our code should not only be nice to write, like our implicit code, but it should also actually tell you what it does so obviously that it is impossible to miss, right? So here it's just like, well, yeah, duh, of course Fusion knows about our dependencies. We're literally telling it with the use function. It's so easy, right? Like, you look at that, you immediately know how every single component of the system is working, because it's simple and it's made up of small pieces that are very easy to understand individually. It's not a big monolithic mess. It's just that one thing has one purpose. So I think this is really good. But again, it's boilerplating. So what I'm going to do here is I'm going to tell you how I've sort of gone the opposite direction again to sort of get rid of the boilerplate, but in a way that sort of still keeps the advantage of this approach. So dynamic dependencies explicit here, and then we're going to add unwrap into the equation, right? So instead of using width get and height get, we're going to use unwrap plus unwrap height. And use selector, so we'll say if unwrap selector, then use width, return unwrap width, use height, return unwrap height, and then unwrap height here as well. And obviously we need to unwrap these. Like that. And now, so this is sort of like the future where, you know, Fusion has adopted unwrap officially, we have use officially, and so this is what our code is looking like. Now, I want you to just take a second to really process that code and see if you can find any patterns, anything that we can sort of clean up, anything that Fusion could perhaps make our lives easier with, any recurring themes. So just in case you can't see it, it is that whenever we use, it's often very closely followed by an unwrap, right? So we have use width, unwrap width, use height, unwrap height, use selector, unwrap selector, use width, unwrap width, use height, unwrap height, and then again, use unwrap. And the only case when we don't do that is when we just unwrap a value by itself, right? Either that, or if we just define a dependency without using its value, which is an interesting thing to do, but sometimes you do it, right? So wouldn't it be nice if there is a way to do both of those things in one step? Now, obviously your first thought is that, well, we're just going back into implicit dynamic dependency land, right? Because here, get does both of those things at the same time, and that was a problem, right? Because there was no way of getting a value independent of setting the dependency. But actually, here, that doesn't seem like it should be so much of a problem, because when we use a dependency, we're not getting a value, and when we get a value, we're not using a dependency, so we already have two things separated out. So all we need is a way to do both of those things at the same time. And we don't even need to introduce a new function to do this. There is actually a good design here that we could take advantage of. See, here we just have use floating about, not doing anything for our actual logic. What if we sort of defined use not just to add a dependency, but then to also unwrap the value for us. That'd be really useful, right? Because then we could use in line, right? So this does the same thing as before. It's just that use, in addition to adding a dependency, is now unwrapping the value so that we can then use it straight in our calculation. And similarly, if we continue to apply this philosophy elsewhere, use selector, then return use width, else return use height. In fact, this code is now so simple, we can replace this with our old if expression. And this reduces the size of our code considerably without making it any less readable, which is fantastic, right? And we could do the same thing here, use height. And notice here in our debug statement, because we don't want our debug statement to add any dependencies, we don't use, right? I mean, of course, get height is going to have to take in use as an argument. I didn't originally write that in the code. But this is also, again, a good change because it means that when we're getting the height, we have to specify where the dependencies are going to go explicitly, which is good because that makes it part of the function's contract, which means that the code using it expects that to happen because it has to allow it to happen. And if it doesn't want to add dependency, it can just pass unwrap instead of use, right? Fantastic, right? It's all coming together. And so you can suddenly see, you know, compared to our implicit code, we really haven't added any new line counts, right? We are at the same sort of vertical size, except our code now has two big advantages. The first one is that it works with both constants and state. So we can change height to 25, selector to false, and width to 50, right? Just get rid of all the state objects. This does exactly the same thing, except it works in terms of constants. How fantastic is that? Right, we don't have to change the syntax because we changed our data representation. We only change the syntax when we change the semantics, which is where we want to be. And the other benefit here is that we are now being explicit about handling dependencies, but we're doing so in a way where we're not actually adding a bunch of boilerplate code, right? Here, we're being explicit that we are using the width as a dependency and we're using the height as a dependency. And here, we're being explicit that we are using the width or the height as a dependency conditionally based on using the selector, right? It's very clear when we are using something versus when we are unwrapping something because they are quite literally two different functions. And so it means it's very explicit where the dependencies are coming from, which means less debugging time, less unexpected behavior. In general, much cleaner code, much stronger guarantees. Theoretically, it's so much more beautiful while still retaining all the same power that dynamic dependencies have. And the best thing is that this scales to components, which is, of course, where the bulk of Fusion code lives, in functional components. So actually, if we just get our button example back, so you see this whole props.name equals make state props.name. Well, actually, we don't even need that anymore. We just use. Just like that. How brilliant is that, right? You don't need to do any extra work here than what you would normally do with the old object notation. You just use the name. And in fact, we are doing less work here because we don't even have to instantiate the state object. So, there you go, right? It's a perfect solution, or at least the most perfect solution that I can think of. Right, it has everything. It has no boilerplate, and it has really pretty code. It's basically no more effort to write out than the object notation. It just looks a tiny bit different than what you're used to. And yet, it's a more honest, theoretically beautiful, explicit, strong guarantees kind of code, right? This is something that is theoretically elegant and still wonderful to work with. I don't see a downside here. Like, this is what I think the future of Fusion's dependency management solution should look like. I mean, hell, we could get better performance out of this. That's how good this is. We are having our cake and we are eating it at the same time. So, I'd be really interested to hear what you guys think about this. I mean, obviously, this is a really big deal to me because Fusion's like half my life right now. But yeah, there we go. So, if you're wondering, I will be commenting on GitHub about this. I'll be linking to the video and everything, sort of explaining these ideas. But I'd just love to hear what you think. I want to hear if you have any suggestions of this sort of garden variety where it's sort of like the way that we're currently doing things in Fusion could be improved with a small sort of perspective shift like this, where instead of focusing on solving this small problem, why don't we fundamentally rethink a larger thing that then leads to a more elegant solution? I'd really love to hear what you think along those lines. And of course, now is the time to suggest that because we are in early beta, which is when all the big changes happen. So please, 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 please comment below if you have any thoughts. I'd love to know what you think. Anyway, I've been Dan, and I'll see you guys next time. Have plenty of fun with Fusion, and I'll see you around. Have fun.